I'll be talking about Python and Iceberg today. So the title is Developer's Guide to PyIceberg, just a thing. Cool. So I'm Kevin. I grew up in New York. I went to Northeastern, and I'm currently living in Seattle. I just repurposed this slide from somewhere else. I used to work at Data Infra at Stripe, and I'm currently an Apache Iceberg committer. Kind of small. So for those of you who don't know, Iceberg is a specification. There are different libraries and I guess integrations with it and implementations of it, mostly in Java, but there's also one in Python. It's called PyIceberg, which is a hyphen, but the actual project is called Iceberg-Python. What it is a Python implementation for accessing Iceberg tables, specifically without the need of a JVM. And it's a Python library for programmatic access to Iceberg table metadata, as well as table data in Iceberg format. It's a Python implementation. That's all you need to know. I copied and pasted the two of those lines from the project. Cool. So today I want to talk about the project itself and some of the components within there. And the idea is for developers, if you want to integrate with the project, if you want to use it for your specific use case, you have a general overview of what is what the capability, what's in there, how to use it, and yeah, well, let's go into it. So catalog is one of the important pieces in an Iceberg deployment. There's a catalog interface, which engines use to interact with Iceberg tables, perform commits, all of the nice stuff. And similarly, in the Python world, there's a catalog interface, and the interface has some functions. These are functionalities that what a catalog represents. There's a couple of different implementations of that interface. So one of those is the REST catalog interface, which means you're talking to this catalog service through an HTTP RESTful manner. There's also the SQL catalog, which is backed by a database, and then Hive catalog, Glue catalog, DynamoDB, and custom catalog implementation if you want to make your own. I have someone come up to me and want to do a DuckDB one, super interesting. And yeah, it's an interface, so let's talk about its functionalities. So I'm just gonna mute this. Can I mute it? Because I hear feedback.
Is it because
I
of
just
mine?
muted that. Okay, so functionalities. You can list namespace, create namespace, drop namespace. A namespace is just like kind of a container for a table. You can think of it as like your database, like traditional in a database, you have schema, you have table, and that's what a namespace is. You can do stuff with the namespace. You can also do stuff with the tables. And then, there are some of the other ones like register table or rename table. These are, similar things that you would expect from like a database. And this is just a way. Okay, cool. And then this is just a way to interact with a catalog. Okay, so similarly, the other part of Iceberg is the underlying storage. So traditionally on S3, on Azure, on GCS, you want to interact with your object store somehow, and this is done on the PyIceberg interface. There's actually two implementations in the Python world, in the Python library right now. One is called FSspec, and the other one is called PyArrow. FSspec is more lightweight than PyArrow, but PyArrow is more feature-rich. So, and it's called PyArrow because it integrates with the Arrow ecosystem, which is backed by a lot of really cool projects. And the File.io interface is also available to create the object storage of your choice. So S3, HDFS, Azure, GCS, and the local file system as well, if you want to try this out on your local desktop or laptop. And it's very simple. It's just create, exist, open, delete. It's just things that you will interact with the object store. So with those two pieces, you can interact with the catalog, do catalog operations, interact with the cloud storage, do operations there. And then there's this concept of a table, which is what people are familiar with as Iceberg Table. And internally, it's represented through Pydantic, which is like a library for like validating and creating Python objects. And the table has like metadata, has different types of metadata. There's V1, V2 metadata. There's name mapping, snapshots, and all the traditional like Iceberg ideas belong to this table. And this is how you will interact with the table itself. And then, obviously for like data, for tables, you want a schema, like data types. You define what your table means, what data goes in there. We have a class for creating those data. It is integrated well with the Iceberg data types in the spec. So all of the data types in the spec are also available in the Python library. It also integrates really well with PyArrow, which is the Arrow ecosystem. So you can exchange schemas from PyArrow to the Iceberg schema and vice versa. And this is really interesting to integrate with the rest of the ecosystem. And then, yeah, schema assignments, schema ID assignments. That's like a Iceberg construct where you want to assign IDs to your data types, your schemas. And then, with any of these like nested stuff, there's a lot of visitors. So the code's available online. Partition. So Iceberg has this concept of partition. You want to partition your data. You want to separate your data into like different sections, I guess. So there's the idea of partition field, partition spec in PyIceberg as well. There's also partition transformation. It enables hidden partitioning as part of Iceberg. So you can, take your date string, translate that into like a date partition, a month partition, a year partition. You can truncate it. You can do a lot of interesting things to transform that partition value. Cool. So, I just went through a lot of the Iceberg concepts that are now in PyIceberg itself. And these are the building blocks that the library uses to enable these kind of behaviors, these functionalities. So one of those is the read API. Through the library itself, I want to be able to read an Iceberg table. What does that mean? I need a catalog to provide me what the location of a table. I need the actual table object itself. And then given that table object, I can do a scan of that table. So, imagine your SQL interface, you do select star from my Iceberg table where your filters. Essentially, it's what the scan API is doing. You take your data that's represented by a table, you call scan, you can pass in filters, you can pass in projections, like if you want only certain columns. You can time travel, which is the Iceberg concept. You can say, what is my data from like 3 days ago? You can send in a snapshot ID to enable you to time travel. You can set a limit. If you don't want to scan the whole table, you can say, just give me the top the 5, that's it. And this is all part of the read API. You can scan through the scan method. And then there's also toArrow, which materializes underlying data in the arrow format. And this is super interesting because this means you can integrate with like other projects that are part of the Arrow ecosystem. So DuckDB is Arrow native, PySpark, Pandas. You can interchange data from those libraries into Iceberg itself. There's also, to batch reader. So sometimes, there's a lot of data. You don't want everything in memory. You can do it in batches. And this is a functionality that the Arrow ecosystem and the integration provides. Is just to read in an iterative format. And then there's predicate pushdown, which just means, you take a filter and then you want to use that information as much as possible to grab the least amount of information. So like partition information, you can say, I just want a specific column. And this maps really well to the Iceberg concept, to the Parquet concepts, because it really filters your data down to specific partition level, specific file level, and even specific sections of that file, so that you don't have to read your like 10 terabyte data for a scan. You can just say, I want a slice of it, And this is where, the power Iceberg comes in because of all the metadatas. And then there's a feature for positional delete files. If you do deletes, you can write these position delete files so that you don't have to rewrite your entire data files. You can say, hey, like I want everything except this location. Those are delete files. The read API is able to read that and give you the data with the delete files applied. And it's in Python, it's multi-threaded. If you want to read 10 different Parquet files, we enable multi-threading for you. It comes with the library, which is super nice. And yeah, so a counterpart to that is the write API. So, I have a table, I want to write some data to it. How do I do that? There are a couple different ways. So there's append. If you just say, okay, I don't care what data is in there, I just want to append a data frame, an arrow data frame. I can just do that really fast. There's also delete. So I could say like I want to delete certain files, certain data frame or certain partitions. I can provide a filter and the library will propagate that and save it to the table and the catalog itself. There's overwrite, which just means, it's a delete plus append. So if I want to say I want to overwrite certain data with my new data, either that can be through a partition or just a row itself. You can do that through the overwrite method. It's also multi-threaded, and then it supports partition writes. That's a new feature that was added recently. There's no merge on read, and it cannot write delete files yet. So there's this concept of like writing delete files, merge on read, and through the write API, we don't have that functionality yet. So like the position delete files that we're talking about, it's not available yet. If you want to contribute, there's probably an issue online to contribute that. And yeah, so like the delete and the overwrite APIs, they're all called like copy on write, which just means, I have some existing data files on disk in my blob storage somewhere. When I want to manipulate it, instead of like deleting like just specific row, I have to overwrite the entire file and then commit that. So it's a more bulky operation, but than the delete files, but this is what we have currently. This is really cool. So one of the interesting thing for Python Iceberg is that it's really easy to get started. You can just do pip install PyIceberg, right? If you have Python installed, if you have pip install, you can just do pip install PyIceberg, and you have the full functionality of the library at your disposal. It comes with a CLI interface, just with the library itself. So you can do PyIceberg as a command line argument, and then you can do -- help. It gives you all of the functionalities. You can list, and this list means I interact with my catalog, and I want to list the namespaces, the tables. I can describe a table, describe a namespace. I can see what files are there, the location, property, schema, all of the above. So I can say, given a catalog, I can see all the tables in the catalog, and then I can go to a table in that catalog and say, give me all that information about that table. Traditionally, you have to have a Spark already set up, or a Trino already set up, or some of the vendors already set up in order to do this, to even look at your the information for your Iceberg table, or you can just go to your object store, but that's harder. But PyIceberg, you could just say, hey, connect to my catalog. There's some kind of configuration involved, and then you could just say through the CLI interface to do some read operations on the table itself. Super helpful. You can do it as a JSON output. If you're writing an Airflow job somewhere and you want to know certain state of your table, it integrates really well with that. If you're in the Python ecosystem, it integrates really well with that. It's just overall a really cool tool to have. Speaking of tooling, this is where we're now going into like some of the feature set of the library itself. Schema Evolution, one of the really cool things about Iceberg is that you can involve schema through metadata. You're able to do that with the library. We have specific features for that. You can say, given a table, I want to update the schema. I want to add certain columns, remove certain columns, whatever you want to do with the table schema, you can do it through the library itself. Again, no JVM involved. You don't have to run a Spark, run a Trino, or run your vendors to do this. There's partition evolution as well. So you can do that through the library tooling itself. You can do table property updates. Anything that you want to do to update your table, it's probably available. And if it's not, it's just a feature gap, and the library is evolving and we'll add more and more features to it. But yeah, I just want to point out this is super cool because usually you got to go to your Spark and write Spark commands and have everything. But this is like pip install PyIceberg, and you can just write this in your Python. Not recommended in production settings, but if you wrap it in a nice environment, it gives you the functionality to do that really, really easily. Similarly, so now you can see what my catalog is, what my table is. You can go into the table and get information about that Iceberg table. So there's a set of inspection APIs. We call them inspection APIs. Spark calls it metadata table. Trino calls it metadata table. You can say, given my Iceberg table, what snapshots are there? What partitions are there? I mean, just read down the list, essentially. Like, if I want to know what the files in my Iceberg table are, I can just call, table.inspection.files, right? And you can see that, once I have a table, I can say, okay, give me all the snapshots. And this is really interesting when you're in looking deeper into your Iceberg deployment, how to work with it. And the cool thing is, because it's in the Python ecosystem, I could just turn this into a pandas data frame, and now I can run SQL on my snapshot. So if I want to calculate when the maximum or the latest snapshot was and what time it is, I can just write a SQL against this, and it just works. Or if I want to calculate how much data is in my Iceberg table, I can say, give me all the files, which has the bytes information, and then I can just do a sum of the bytes information. And that's a really easy way to know about my table. Kind of already touched up on this a little bit. The nice thing about Python and the ecosystem is that there's a lot of really cool integrations. So Arrow, Pandas, DuckDB, Daft, which is a distributed SQL-based, Python-based SQL engine. Want to get that right. And then Ray, which is used in the ML world a lot. There's functions within the library that can work and integrate well with these ecosystem as well. So it's just a really nice way to, if you run an ML service with Ray, you can come to Python and Iceberg and have that interact really nicely. Again, on the tooling part, a lot of the feedback from people in the community is that, how do I get started? I need to run a catalog. How do I do that? Should I do that? If I just want a POC, what should I do? With the library and some of the components, you can do an in-memory catalog, which just means you run a catalog in your Python program that exposes the catalog interface, but all the metadata is in memory. So I can just I don't need to connect to an external service in my Python project. I could just run a catalog and it's in memory. Similarly, if I'm playing around with it on my laptop, I could just say, instead of writing it to memory, write it on disk so that, my other Python projects can also read it. Not recommended for production setting, by the way, but, for a lot of interesting toolings and interesting, if you're in a CI/CD world or something, you just want to catalog really fast. This is a way to do that. There's static tables. So, sometimes you just have a metadata JSON or someone just throw you a S3 bucket and say, here's my Iceberg table. You can just take the metadata JSON and it turns into a table, which means you have all of the great tooling that we just talked about. And yeah, so static table also means that you don't need a catalog available to you. You can just take a JSON metadata JSON file and bam, there's a table. And yeah, kind of alluded to this a little bit. One of the kind of difficulties with getting started with Iceberg is all of the components and all of the infrastructure you need to set up. So traditionally, you have a Docker, you have a bunch of services that the Docker spin up, and then you interact with it through Spark or something or a Jupyter Notebook. But this is a super easy way to just set up everything, right? I can say I have a catalog as a Python object that is written to disk. And then I can say instead of S3 or any file storage or like object store, I can just write it on disk. So with my laptop, I can have a full Iceberg infra spun up and I can like play around with it, right? Super easy, super cool way to like understand what's going on. I can commit a table and I can just see what exactly is written to it, the metadata JSONs, the like all the different types of files. And then, it's a quick and easy way to like learn about the concepts. And, it bends the learning curve a little bit because you don't have specialized setup. And then this is enabled by both, the catalog from SQLite and also the local file system support. And yeah, so quick roadmap. We just had 0.8.0 out. It's been a lot of work in the last couple months. There's a link to the dev list. So if you want to get involved, go to the dev list, try it out. There's a voting process and like a release process that you can verify. It's very nice way to like interact with the project. So vote, we're trying to vote and get the 0.8 out to the community. We want to do table management. So, like there's a amount of things that you want to do for your Iceberg table that's not available in PyIceberg so far. It's available in Trino, Spark, all the other stuff. But getting those functionalities into PyIceberg will be really nice. Maintenance operations as well. Branching and tagging. WAP just means write, audit, publish. It means, I can write to a branch, check it before I expose the data to like everyone else, which is great because, typically ETL, you don't want to expose your data too early before you do the checking. So it's a really nice pattern. Speaking of integrations, Rust, Iceberg Rust, which is the library written in Rust and all the great functionalities in Rust, there's a nice integration with Iceberg Python where you can expose Rust as a Python interface. And that gives you a lot of like performance gains. So like, for example, the partition, writing to a partition when you want to do the transforms, sometimes the transforms can be very costly in terms of compute. So like, for example, if I want to do a hash, that hash costs a lot. We want to do it in the Rust world and then translate that back into Python so it's faster, but it exposes the same interface in Python. And then there's a link to the I call it a roadmap, but it's just a link to a bunch of issues on GitHub right now. And I'll provide this slide online. It's publicly available. And there's many more stuff come in. Yeah, so if you're interested in contributing, the GitHub link and the documentation link is over there. Documentation is always needed. That's one thing I feel like for a lot of open source projects. The people who are working on the open source projects typically like don't see what is missing to a beginner, right? So if you come in and you say, okay, I don't understand how this works, it's a great way to contribute back to the project because the next person come in can learn about the documentation, the kind of ideas around that. There's been talk into creating cookbooks. So these will be like, how can I do X? So like things like, how do I create an in-memory catalog would be a great place to put in the cookbook. And like, we're trying to gather as many functionalities as possible so that, people who are looking for how do I do this in PyIceberg can just go there and then, it's a community-driven project. And then, if you want to contribute, good first issues on GitHub. It's a great place to start. Go to the Python channel on Iceberg Slack. And then there's a link to the community sync, which is every month. And join us. And there's some links. But yeah, questions? Yes, spinning.
Hey, so yeah, great presentation. So I saw that the read and write paths are multi-threaded.
Yes.
So like during execution, like how is there like a query profile or execution profile I can look at to say like maybe there's a data skew problem. So is there some kind of profile that I can look at?
Yeah, but not from the library itself. There are a couple of projects that will profile a Python program for you, so you can use that. In terms of like, are you talking about in terms of query plan or how my Python project is running?
Yes, the execution, like if it's multiple threads,
Yeah.
let's say they're reading, right? And you have a data skew problem because the array are evenly distributing their data, right?
Yeah.
So how do I see that?
Yeah.
A question for the recording purpose.
I think he has a mic, so it should be. Oh, it's not connected? Okay.
Thank you.
I think the question was, how can one profile the read and write APIs? Is that correct?
Yes, the query protocol.
The query profile for read and write APIs. That's interesting. So there is a plan files API, which just gives you the plan for like, here's what I'm going to do before running it. And then there's the actual integration with PyArrow of like going there and getting the Parquet files, filtering and doing all of that. So there's two parts to it. The plan API is probably what you want to do because once you plan it out and say, here are all of the data files that I'm going to read, that you can maybe look at the data files to see a skew there, but I think it's not really thought out how you would do that.
Thanks.
Yes. Yeah, so the question is, using the REST catalog, there's an integration where you can send credentials, right, to the underlying, for the underlying file system. And yes, it's supported. So like if you run a catalog right now that supports vendor credentials, PyIceberg will take that. So you don't have to take you don't have to supply your own credentials. I think. I'm like 90% sure, but I'm pretty sure it's possible. Yeah. I mean, oh,
So on the roadmap, the Iceberg Python, I'm wondering if long-term roadmap by Iceberg, if plan to execution of Iceberg with something that execution, so say it's a bus and
yeah. So the question is between integration for PyIceberg with either Iceberg Rust or some other kind of native execution engine. Yeah, I think that's a really good question. Right now, everything is very tightly coupled to PyIceberg. So like, to PyArrow. And all the reading and writing is done through the PyArrow library, which, it's arrow backed, but it's the Python version of it. So, one of the reasons for integrating with Iceberg Rust is that in the Rust ecosystem, there's a tighter integration or a better integration with some of the execution engines, right? So the idea is, you can integrate with Rust, which integrates with the rest of the ecosystem and on the Rust side. So you can have native execution engine. There's a lot of great work in the data domain on the Rust side too. So first step is figuring out how do we integrate Iceberg Rust and also Rust projects into Iceberg Python. Second step is to do further integration with the rest of the Rust ecosystem. Yep. Well, thank you, everyone.
I do have one last question. So, Schema Table management is still something to talk about. Do you support the migration APIs?
Yeah, so the question is, does the library support migration APIs? And that's the register table, add files. So those are all supported. They're part of the catalog interface. And if not, they should be supported.
The last question.
When you have like going for a disaster recovery kind of thing, like if you want to store once the files, like one bucket to another bucket, or you problem. I seen metadata files has some hard-coded bucket names. When mirror the files, including metadata and actual data, contains some hard-coded bucket, like where exactly the relative path of the file is. So when it comes to disaster recovery, how can we, along with the metadata files, like snapshot files, data files, we mirror region or other?
Yeah, so the question is around disaster recovery, and specifically, how do you deal with that with Iceberg, especially with the static kind of reference to other files on disk, or like in the object store. So like your metadata files will have a reference to a specific path on S3, right? So there are a couple different ways. I think like one way is to just replicate your data files and then reconstruct that the table somehow. There's also a location provider interface within Iceberg, which just means, you know, I can say I'll do write when I'm writing, I can write to multiple locations on S3. That's available, but there's different kind of levels of abstractions depending on where you want to go. But like if the purpose is for like, you know, I want to store another set of data files somewhere, I think maybe reconstructing it is better. Or otherwise you have to rewrite those metadata files somehow, right? Yeah, because it's written on disk. So, and the files are technically immutable. So you don't want to like go and modify it to reference something else. Interesting question. I wish I could say more, but I think, you know, making sure that data files are, have the disaster recovery features first is probably number one. And then rebuilding those data files into your Iceberg table is possible. Like for example, I can say, you know, my original table has certain partition values, has certain schemas. I can take those and just like go somewhere else with a new bucket and just reference the same data files, right? Or like, you know, reference your copy version of the data files and rebuilding that, what that table looks like. So that's like another way.
Yeah, I think the previous question. I think the problem right now, the Iceberg has two parts. The proposal of using the we can define the root and just then if we let you not fail over, then we can change the one. But that's not real today. You know, we even do the reconstruct the table then.
So I'm just going to repeat it for the audio. So right now, Iceberg use absolute path. And if there's a proposal for relative path, which would be a lot easier to deal with because, you know, you don't have to hard code a certain bucket or a certain path to it.
Yeah, so I think Delta Lake has a good feature for this. They call it cloning. We have soft clone and deep clones that actually copy the data. Maybe that's something that we.
Did you have a question?
Yeah, so on the snapshot versions, let's say if you have huge tables, is there any best practice around how many versions we can maintain, or it doesn't impact the performance?
How many what you can maintain?
Snapshot versions, like every change.
Oh, snapshot versions. Oh, so the question is around how many snapshot versions you can maintain for good performance.
Yeah.
Right. Yeah, I think there's, you know, table maintenance to make sure that you can compact the metadata as well. So, you know, you can, it really depends on your query pattern, right? But if you start reading a lot of metadata files, right, when you have a lot of snapshots, when you're doing, I mean, typically it's not on the snapshot level because snapshot represents like a state of the table at one point. But if you have a lot of underlying metadata, right, which points to the data itself, or like a lot of delete files, when you start reading a lot of those files in order to query, that's when it matters. And there's a lot of like maintenance jobs to deal with that. You can compact it so you read fewer files at read time, or yeah, there's just a lot of like knobs you can do to like fix those issues. Yeah, cool. Thanks everyone.